The same exercise, bonding and structure, question 58. The element sodium and compound sodium chloride both are solid at room temperature. Name type of bonding in sodium and explain how this bond holds the structure together. So sodium is a metal, and what is we have to just explain the metallic bonding. So there is a metallic bonding and how metallic bonding occur. So it is an attraction between the positive ion and the delocalized electron. So 2 marks are there. 1 mark is for mentioning the type of the bonding, which is metallic bond. And the second thing, strong force of attraction or electrostatic attraction between the positive ion and delocalized electron. Then name the type of a bonding in sodium bromide and explain how this holds the structure. In sodium bromide, because sodium is a metal and bromide is a non-metal, so what kind of bonding they will have? They will have ionic bonding. And how this ionic bonding, like the structure is held. So there is also electrostatic attraction between the oppositely charged ions of bromide ion and sodium ion. So answer here, it will be an ionic bond and electrostatic attraction between oppositely charged ions. The next part, the table shows the melting temperature of a sodium and sodium bromide. What can you deduce from these data about the bonding in two substances? So what we can say about the bonding, as we already mentioned, and in this case, when you check the melting point, it is 371 for sodium, but in sodium bromide, it is 1020. So which one is stronger force in this example? In this case, ionic, because sodium bromide is having ionic bonding, so we can say ionic bond is stronger, but it is not like a universal statement. It is always true. It depends on the type of a substance, because metals also, some metals have high melting point and ionic compound. But according to this data, we can conclude that ionic bonding or ionic bond is stronger than metallic bond. This is according to this data, but this is not a universal statement that always ionic is stronger than metallic. Then name one physical property other than the melting and the boiling point when sodium and sodium bromide, which sodium and sodium bromide differ in their bonding, and describe how this property differ for each substance. So melting point or boiling point is one of the property. What else we can say? We can say about electrical conductivity, like solid sodium will conduct electricity, but sodium bromide will not conduct. We can also say about malleability, because metals are malleable, but ionic compounds are like brittle. We can also say hardness. Hardness is metals are generally hard, like compared to ionic compounds, metals are relatively softer. We can also compare the density, like sodium density will be lower as compared to sodium bromide. So any one of the property we can mention, the simple property, we can compare the electrical conductivity. In electrical conductivity, solid sodium will conduct electricity. But sodium chloride, sodium bromide cannot conduct electricity. Ammonium ion contain covalent and dative bonding. Describe the difference between a covalent and a dative bonding. So what is the difference between a covalent and dative bonding? In covalent bonding, the electrons are equally from both atoms. The electrons involved in the bonding are from both atoms. But in dative bonding, the electrons are coming from only one atom. So covalent electrons shared between the atoms equally from both atoms. Wherein dative covalent, you can also say it is a dative covalent or coordinate covalent or dative. The electron shared between the atoms from one atom. Then we have to draw a dot and cross diagram for ammonium ion. So ammonium ion, we have nitrogen. First, it will form a bond with, use the symbol cross for hydrogen and circle is for nitrogen. So nitrogen share with, this is ammonia, but we want to draw ammonium, so nitrogen lone pair, and then there's also another. And you should make a charge here. Either you can put a charge on this hydrogen or put a charge on overall, but only one side. Don't put charge twice. Only either you put on hydrogen or a proton or the overall molecule. Suggests how an electron density map of ammonium chloride provide an evidence the presence of ions. So how we know that ammonium chloride is an ionic compound or ions are present? As I mentioned in explanation of the electron density map, that if it was a covalent compound, the electron density map, like there are lines which are around both, like there are common lines for both atoms. But in ionic structures, there are separate lines for each ion. They are not overlapping with each other. In covalent, the line, there's a one line around, or lines are there around both atoms, or there are common lines. So how this gives an evidence? So in the electron density maps, the lines go around the ions and not around the nuclei, or do not overlap with each other. So the lines will go around the but they will not be around the nucleus. Or nuclei. Like there's no common line which are completing both the nucleus. But in covalent it happens, but ionic it does not happen. In question 59, what is the equation for electron affinity? Electron affinity means when electron is added to a neutral gaseous atom. You can see here sulfur is there, electron is added from sulfide ion, so B is the right answer. Which of the following ions has a biggest radii? So again, we did this. Biggest is there, so that will be sulfur. The same options are there. Smallest is calcium because more proton, less electron. Which is there being the smallest ionic radii. So we have to write here 8 protons, 10 electron. Here 9 protons, 10 electron. Here 11 protons, 10 electron. 12 proton, 10 electron. So smallest means more attraction. So the one which is having more protons, more attraction. So it means D. But if they say largest, so in that case it will be oxygen because few proton and more electron, like greater difference. What is the equation for the lattice energy of magnesium? So ions in the gaseous state will form a compound. Magnesium ion into chloride ion for magnesium chloride in a solid state. So C will be the right answer. Which of the following compound has the greatest ionic character? So greatest ionic character means it should have a greatest difference between the electronegativity. When we move across the period, so greater covalent character means a smaller difference in electronegativity. Greatest ionic character means greater difference in electronegativity. So as we move across the period, electronegativity increases. When we go down the group, the electronegativity decreases. So cesium is there, fluorine, potassium, and iodine. So means the one, because as we go down, so this will have the smallest electronegativity and this will have the highest electronegativity. So if we take the smallest and the highest, they will have the maximum electronegativity difference. That's why for question 63, A will be the right answer. Because we want a greater ionic character. If the same question was there, greater covalent character, then we check which is having the smallest difference in the electronegativity. Which species has a dative covalent bond? So which is having a dative covalent bond? When we draw the structure of water, two covalent bond and there are two lone pairs on oxygen. When hydroxonium ion or H3O, one of the proton is attracted toward the lone pair. So as a result, it will form a dative covalent bond. So A will be the right answer. Then the atomic radius of a potassium is larger than sodium. This is because, so what is the reason why potassium atomic radius is larger than sodium? The size depends on the number of occupied. Like potassium is having 19 protons and 19 electrons, where sodium is having 11 proton and 11 electron. So more electron means more electron shells are there. Not the larger nuclear charge, it is correct, but that is not giving an evidence to an increase in size. The statement is correct, but not refers to the why it is larger. Larger nuclei also or nucleus also statement is okay, but not according to the reference. So C will be the right answer. More occupied shells. That's why strong, higher, larger size. In question 66, the lattice energy of sodium fluoride and magnesium fluoride are there. Explain in terms of size and the charge why lattice energy is more negative than sodium. So magnesium is smaller in size, magnesium ion. Then magnesium ion is having a greater charge. Because both are fluorine. So magnesium, it's of three marks are there. So first thing, magnesium ion is smaller in size, that will give you 1 mark. Then magnesium is having a greater charge, that is another. And magnesium is having a greater, or you can mention greater charge or charge density. And the third mark, so there will be strong electrostatic attraction between magnesium and fluoride compared to sodium fluoride, or stronger ionic bond. So 1 mark is for mentioning size, 1 mark is for charge, and the third is for mentioning stronger attraction. Which is having the highest, largest ionic radii. So we know like 8 protons, 10, 11 proton, 10, 12 proton, 10, and 9 proton and 10. So because less proton, more electrons, so weaker attraction towards the electrons, so larger size. Which of the following observation provide an evidence for presence of ionic bond in unknown substance? Like in unknown substance, there's an ionic bond. So what is the evidence of existence, like saying that there's an ionic bond? So substance conduct electricity in solid state, ionic compound cannot conduct. Substance conduct electricity in solid and aqueous. Solid they cannot, aqueous yes. In solid state and molten it can conduct, in solid it cannot. When molten but not in a solid, that is true. So D will be the right answer. So these are some questions from the assignment. There are about like 100, more than 100 questions are there in this assignment, which is about like 101 questions. So assignment: bonding structures and shapes of the molecule.